Hello ladies and gentlemen, today what we're going to discuss is domain and range. This is part one of two that we're going to have dealing with domain and range. Today we're going to talk about part one. In class we'll do part two. What we're going to talk about is domain and range of a situation. So, start off with a few things you can write on your paper if you'd like to. Less than, greater than, you got less than or equal to, or greater than or equal to. Make sure you know what each symbol stands for. That's going to help you out while you're doing this stuff. We've talked about this a little bit. We're talking about our domain and range given a continuous situation. This is a line segment. We've talked about each one of these. Domain, when we have x, our independent variable. It might also be written like this when we talk about a set. Right? So these two things are basically the same idea. The range over there, again, that's talking about your y-coordinate. Your dependent variable. So if you see either one of these, we're talking about a continuous situation. Right? You've seen these before also. This is just a single situation.
Mr. Danos is on the bus loop now. Will the students looking for him please report back to the bus loop at this time? Mr. Danos is on the bus loop at this time. Thank you.
So, sorry about that. Right. So as we look at this, this is just dealing with a situation that continues on. X is less than 5. I'm talking about domain again, also with y. Alright, just want to give you a couple of examples of things you could see. But to start off with, first example, top of your page. The airplane is 2,500 miles from the city of Houston. It's traveling 150 miles per hour towards Houston. X represents the number of hours, y is your distance from Houston. First off, we want to write an equation. Now you can set up a table. You can go through, if you would like. You got number of hours. Alright, then you got miles from home. Okay, and they can tell you all this. At 0 hours is where you're going to start. Remember, that's your initial value. Alright, your starting point. Well, your starting point is again 2,500 miles from home. After an hour, they're going to be 150 miles closer. So if you're going to do that and you're going to look for your rate of change, you want that to be a negative 150 because you want to get closer to home. Right? Which again would put you at 2,350. You can keep going like this to get to 200. Okay, and you can get your rate of change from this. So rate of change, change in y over change in x, negative 150 over 1, 100, negative 150. So that's your value m. Alright? The initial value b is where you started at, 2,500. So, or 2,500. So, if you look at this, in slope-intercept form, y equals mx plus b, that linear function form. Y is equal to negative 150x plus the 2,500. Now, it asks you, what's the domain for this situation? Well, think about it. What are we traveling by? Hours. So if we're writing domain, right, it's going to take them a certain amount of time to get home. Well, you take the 2,500, right? How long is it going to take them to get back? Well, if you take the time it takes him to get the number of miles divided by how fast he's going, right? You can get how long it takes him to get back. So 2,500 divided by 150, well, that's close to 17 hours. So for writing domain, is this discrete? Is this continuous? Well, mileage, time. You're talking about continuous. So as we write this, what we look at, we talk about that domain, we talked about that less than or equal to x, less than or equal to. Right? The lowest value would be from 0 to the time, which is about 17 hours. So we're going to put from 0 to 17. For the range, as we look at this, well, the range again, as we look at this one, right? Less than or equal to y, less than or equal to. Because again, we're talking about a continuous situation. The smallest value is 0. The highest is how far he is away, which is 2,500. So that's our range for this situation. All right? Now, the next thing they ask for, right, is what's the domain of the function. This is where they're going to get you on the test. Here we ask for the situation. So it wants specifically what's going on here. If I say, what is the domain or range of the function? I don't care that there's an airplane involved. I don't care how far he is away. All I care about is this right here. This up here all means nothing to me when I see this word function. And from what we've talked about before, the domain of the function is going to be all real numbers. Because we're just looking at that. When we talk about the range of the function, it's also all real numbers. Alright? We've talked about this all real numbers before, and that's the symbol we use to describe that. Now, what I want to show you is after you've written all that down, I want you to take a look at this. So, put your pencil down and just look. When we look at these, we have two different things here. The situation. Here's the graph. The equation, the function. There's a graph. If you notice, these two are the same. And they should be right now. Because what we're talking about is we're talking about a continuous situation. But I want to show you something slightly different. This part right here and this part right here. In the equation, it doesn't stop at 2,500 up here. It's 0 and 2,500. It doesn't stop down here, right? A little after 16, almost to 17. The reason why is because in the equation, we don't care that you can't go past 0 for time. It keeps going. So essentially, this should have arrows on the end. All right. Over here, when we look at this, I know they got 16 2/3. I put 17. It's about the same. All right. But what we're looking at here is looking from 0 less than or equal to x less than or equal to 16 2/3. Okay. And for your range, 0 is less than or equal to y less than or equal to 2,500. That's why we put that. But with the equation, we don't care about all that. So that's why we write it in this fashion. If you want to take a minute to write this down, you can. You can look at it. That's what I want you guys to see. We're talking about a continuous situation. The graphs are very similar because they are line segments. This is an actual segment. This one keeps going because we're talking about the equation itself. All right, so the next one. Each person who went through the drive-thru bought a number of tacos and a drink. Below are the receipts for their purchases. Write an equation from the table. Alright, so think about what's going on here. If we're looking at this and we're stating the domain and the range, alright, dealing with what's going on here. You can write the equation. Again, you need to know the coefficient and the constant, your rate of change, and the initial value. Well, change in y, this is y, this is x. Change in y, $1.25. Here we've got $2.50, so on and so forth. All right, you're gonna have like $3.75. Up here, change in y, or change in x, sorry. 2 to 3 is 1, 3 to 5 is 2, 5 to 8 is 3. When you divide these, change in y divided by the change in x, 1.25 divided by 1 gives you $1.25. Alright? But you need to find the initial value. Well, you take that initial value, or you need to take that rate of change, we write it in that mx plus b. Okay? The rate of change is $1.25 times any value of x, let's just use that one, times 2 plus some number has to give me 5. Well, $1.25 times 2 is $2.50. $2.50 plus another $2.50 will give me $5. So as I look at this, my value of b is $2.50. So, I want you to state the domain for this situation. Alright? So as you look at this, is this discrete or is this continuous? When we talk about the situation, can you buy half a taco? No. We do not buy half a taco. So as we look at this, when you start to name your domain, your value of x, right, what we're looking at here, and one of the ways you can write it, and I'll show you another way here in a second, no tacos, 1 taco, 2 tacos, 3 tacos, so on and so forth. That is discrete. When we talk about the range, well, start off with, if we start at 0, this one doesn't start at 0, it starts off at the 250 you start with to begin with. Alright? And that's from your initial value. You buy 1 taco, you add on $1.25. Right? Which in that case would give you $3.75. Add on another taco, $5. Add on another taco, $6.25. So on and so forth. Your domain and range looks different for a discrete situation. The reason why is because you cannot buy half of that. So I want to make sure you see that. Now, the equation again, right up there. Oops, I'm sorry. The equation's right up here. But here's the thing. If I want to know what it is, the domain and range is for the equation, not for the situation, but for the equation. Again, all of this doesn't matter. All that matters is just this. So, if I ask you for the domain and the range for the equation or the function itself, just this, again, all real numbers for both, the domain and the range. Because again, I don't care about number of tacos when I'm talking about the function itself. I just care that we have a function. So as you look at this, here we go. Now as they did it here, they did it by the 2, 3, 5, 8, and 12. They did it by what was given in the table, which is perfectly fine. And then they wrote the range from that also. But I want you to notice, look at the graph from the situation. We talked about this before. If we are talking about a discrete situation, we are only plotting points because the points in between don't matter. That was our discrete continuous day. Here we're talking about the equation only. And if you notice, we have a line because it is continuous. And a function is always continuous. Alright? I want you to see the difference. They are going to ask you about that on the test. They're going to ask you for the domain of a situation. They're going to ask you the domain for a function or an equation. You got to know the difference between the two. Alright, so the next one. Bathtub fills at a rate of 1.8 gallons per minute. Write the domain and the range. Well, if the bathtub holds 80 gallons at most, write the domain of the situation. Well, here's your equation. Y equals 1.8x. It's 1.8 gallons per minute. If it holds 80 gallons, well, at this time, you would just divide it. You've done this before. Alright, you're going to get somewhere near about 144. Or not 144, 44, sorry. So if we want to write the domain, we are talking about the number of minutes. The number of minutes. The smallest value would be 0. The highest value would be 44. So it will be written in this fashion. Alright. Why is it not a set of points? Well, you have to decide. Is this continuous or discrete? We're talking about measurement again, number of gallons. So it's got to be continuous. So it has to be written in this fashion, all right, as a line segment. All right. Next. Okay. John has $20 to buy cupcakes. Okay. Just Dessert charges $1 for the box and $3.50 for each cupcake. Write an equation and model the situation and state the domain. Okay, you've done this. You've looked at this before. But we're going to talk about this again. Writing a function. Writing this equation. Start off with, we always start at the lowest point, so we're starting at 0. Starts at 0, he has to pay $1. It's $1 for the box. One cupcake, I'm sorry, it's $20, I apologize. If he pays, he's got $20, right? Well, no, we'll do it this way, okay? So he buys one cupcake, that's going to cost him $4.50. $3 for the cupcake, $1 for the box. 2 cupcakes, add on another $3.50. So you're going to be here, you're going to be at $8. 3 cupcakes, $11.50. I'm sorry, $11.50, wrong button. Sorry. You're adding on another $3.50. Go up to 4. Right? Add on another $3.50 again. You're now at $15. Again, $18.50. And then you're going to be at $22 for the 6th cupcake. So I want you to think about this. If you look at this, your rate of change, M, 3.5 divided by 1, which is 3.5. Your initial value, what you started with. We've talked about where the x-coordinate is 0. That's 1. So your equation for this one is y is equal to 3.5x plus 1. But if I want to know what the domain is for this, first off, is it continuous or discrete for this situation? Can you buy half a cupcake? And hopefully you answer no. So that's going to be discrete. So if we look at discrete, what we're talking about here is 0, 1, 2, 3, 4, 5. Can he buy the 6th cupcake? The answer is no, because he doesn't have enough money. And that's this right here. He only has 20 bucks. He can't get up to the 22, so he can't get the 6th one. This is very important. When you state that domain, it can only go to 5. Don't write the 6 in there. So if we do the range, well, the range for this, as you're looking at it, 1 for the 0 cupcakes, 4.5 for the 1 cupcake, 8, 11.5, and so on and so forth. All the way up to, and it has to stop right there at 18.5. You can't go any farther. So you've got the 15, and then the 18.5. Alright? That is the range. Again, it's discrete. So that's why it has to be written in that fashion. So, what 2 things do you need to be careful to look for when determining the domain and the range? First, is the domain and the range talking about a function, or is it talking about the situation? If it's talking about the function, it's automatically all real numbers. Automatically all real numbers. Or if we're talking about the situation, you have to figure out number 2. Is it discrete or is it continuous? If it's discrete, you're talking about a set of points. If it's continuous, you're probably talking about a line segment. And that's what that less than or equal to x, less than or equal to. So remember that. Okay? Alright, we'll talk about the second part in class. You'll have a quick worksheet to work on when you get in on either Wednesday or Thursday. Again, if you have any questions, as soon as you walk in, we'll get to it. I'll answer your questions. Alright, have a good evening. Bye.